The title of today's notes is called Boiling Point Elevation / Freezing Point Depression, where elevation means to increase and depression means to decrease. So the first thing I'm going to do is I'm going to draw a container, and let's say it's a container of, let's say it's pasta water. So we're going to boil some water to make some pasta, and I'm going to put some water in there, some water molecules. Now notice how I'm lining these guys up. Now we know that one side of water is negative, oxygens are negative, and we know that the hydrogens are all positive, little bit positive. And what happens is they become attracted to one another. One side positive, one side negative, and that is called a hydrogen bond. So we have our water molecules, and they like to stay together, okay? The positive on one likes to hang out next to the negative on another. Now, when we boil water, all that's really happening is the water molecules, that hydrogen bond that's holding them together, is breaking apart. And it just so happens that you need to add 212 degrees Fahrenheit worth of energy, worth of heat, in order to break that bond. So when the water reaches 212 degrees Fahrenheit, that's when those hydrogen bonds break apart and the water molecules are free to float off and become water vapor, and they float in the atmosphere. Now, your parents might add salt to the pasta water. So I'm going to go ahead and add in some sodium chloride, some NaCl. I'm going to say Na plus 1, Cl minus 1. 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 Now, salt, sodium chloride, it breaks up when it's dissolved in water. Now what happens is the sodium chloride, the salt, actually interferes with water's ability to break the hydrogen bonds. So as a result, the boiling point elevates, or the boiling point increases. So when you add salt to pasta water, instead of it boiling at 212, it might boil at like 216 degrees Fahrenheit, which causes the pasta to cook quicker because it's at a higher degree. So all that I just said, I'm going to write down on the side. So I'm going to say NaCl, sodium chloride, is interfering with the hydrogen bonds between water molecules, comma, causing the boiling point to increase, period. NaCl, that's salt, makes it more difficult for the hydrogen bonds to break apart. So what happens is, if we're trying to boil something, that boiling point goes up. If we're trying to freeze something, the freezing point goes down. So we've got two equations that can help us out with this. They are triangle TB equals KB times little m I'm going to box that guy. And they are delta TF equals KF times little m. First things first, this triangle right here, that means delta, or that's Greek letter delta, and it means change. So we're going to be calculating change, and TB stands for temperature, boiling. TF stands for temperature, freezing. The KB and the KF, those are just a constant. And the little m stands for molality. It's very similar to molarity, but it is called molality, and it's a little bit different. So now you are going to grab your worksheet 15.4. So if you don't have it, pause the video. And we are going to start with number 4 together. So number 4 says calculate the boiling point. So since it's boiling point, it's going to be this formula. So delta TB equals KB times molality. Now notice they give you the molality. They give you that the molality is 2.65 molal, and it's in an aqueous solution. Now that means it's dissolved in water, H2O. Now unfortunately, you were supposed to have a table of values at the top of this worksheet, but if you look in your packet of worksheets, you should find a table like this, and that's what we're going to use for these. So what I'm trying to find is the delta TB equals KB. Now if you look at these tables, you will see you have KF over here, and you will have KB over here. Now you're going to be using the KB, and it's going to be the KB of water. The boiling point of water is the KB of water is 0.512. So that's what I'm going to fill in for KB. 0.512 times the molality, which is 2.65. And your calculator spits out so it's at 1.3568. That is delta TB. Now this represents the change in boiling point or it's how much the boiling point, I'm going to say BP, increased by. So we need to figure out what the actual boiling point is going to be. So if you look back at the table, we can see that the natural boiling point of water is 100 degrees Celsius. So I'm going to take 100 degrees Celsius, and I'm going to add the change. Remember that delta means change. I'm going to add this change, so plus 1.3568. So I add those together, and I get 101, where's my whiteout? Ask for a point right there, make a marking. 101.3568. Now I'm just going to have you guys do 3 sig figs for all of these problems. So the final answer is 101 degrees Celsius. That is going to be the new boiling point. So when we dissolve sodium chloride in water, it causes the boiling point to increase or change by this much, but they wanted us to calculate the actual boiling point. So I take the boiling point of water, I add the change to it, and I get the new boiling point. So let's also go ahead and let's do number 5. Number 5 says to calculate the freezing point. Now in our notes, it says that it's freezing point depression. That means the freezing point is going to decrease when we add sodium chloride or something similar to it. So they want us to calculate the freezing point, so the formula is delta TF for freezing equals KF times molality. So notice it's in ethanol. So if you look at your table that's on one of your worksheets, you're going to use the freezing point, and it's in ethanol. It did say that. Now the KF of ethanol is 1.99. So that's what I'm going to go ahead and write down for the KF. Times the molality, which they give me. I multiply that out, and my calculator spits out 8.955. Now this right here is the change in the freezing point. And it's freezing point depression. So the freezing point goes down. So to find the final answer, I look at what the freezing point of ethanol really is. The freezing point of ethanol is negative 114.1. So I say negative 114.1. And I'm going to subtract, because it is freezing point depression, the change decreases the boiling point. So I'm going to subtract 8.955. And my calculator is going to spit out negative 123.055. And I'm just going to give everything 3 sig figs in this for these questions. So that's negative 123 degrees Celsius. So basically, for boiling points, you calculate the change, the delta, and then you add it to whatever the boiling point was. If it's freezing point, you calculate the change, then you take that change and you subtract it from whatever the freezing point was. Everything in this chapter is in degrees Celsius, so you just leave it in degrees Celsius. So if you didn't finish the worksheet 15.3 for 15.3 in class, that's now homework, and just make sure you bring the notes to class tomorrow. Have a good evening, guys. Garvin, out.